Now, this is the logarithmic scale, and this represents the key information that we're going to have to know in order to do all of the exercises, and it will provide us with an onboard ability to solve problems. In other words, without the aid of a calculator or some sort of a device. And the logarithmic scale is based on for every number n such that n is a positive number. So n has to be greater than or equal to 0. Then n is equal to 10 raised to the log of n. And I will use the convention that log implies base 10. So what you're going to need to do is, right now, is memorize this table. The first 5 prime numbers and e. We need to know the logs of those numbers, and that will enable us to do everything we're going to have to do. And so, for example, if n is equal to 1, 2, e, 3, 5, and 7. And I should probably include that I'm going to, with 3 significant figures, and so this should be 1.00, 2.00, e, and 3.00, 5.00, and 7.00, because I don't want you to memorize these logs to any further to the right of the decimal. This has 3 significant figures in it, therefore this contains 3 significant figures. And so, in other words, if the log has 3 significant figures, that's as far as I want you to carry it. Okay. Now, the log, for n equals 1, the log of n is 0. And for n equals 2, the log of 2 is 0.301. And as we've already seen, if the n is equal to e, then the log base 10 of e is 0.434. And if n is equal to 3.00, then the log of 3 is 0.477. And if n is equal to 5.00, then the log of 5 is 0.699. And if n is 7.00, the log of 7.00 is 0.845. So you memorize these numbers. This is not anything that's too difficult to handle, and then the applications are unlimited. This will free us up. And we're going to have to recall the following 2 important facts that are underlying the whole thing. When multiplying 2 numbers, add the exponents. It always reduces down to that simple thing, knowing when to add and when to multiply. And for example, if 2 is equal to 10 to the 0.301, and 3 is equal to 10 to the 0.477, well, therefore, 6, which is equal to 2 times 3, so this is an easy factor. We can express this in terms of its factor. 2 is 10 to the 0.301, multiplied times 3, which is 10 to the 0.477. Well, that happens to be equal to, when I multiply 2 numbers with a common base, I simply add. So when I multiply, I add. That's equal to 10 to the 0.301 plus 0.477, which is 10 to the 0.778. And the other thing we're going to need to do is when raising a number, multiply the exponent. Again, knowing when to add, when to multiply. And for example, if 2 is equal to 10 to the 0.301 and 8 is equal to 2 cubed, 2 raised to the third power, well, therefore, 8, which is equal to 2 raised to the third power, is equal to 10 to the 0.301, quantity raised to the third power. Well, at this point, when I'm raising an exponential number, I multiply the exponents. So this is equal to 10 to the 0.301 times 3. So when I'm raising, I multiply, and that happens to be equal to 10 to the 0.903. So now let's talk about the exercise number 2, which is going to give you practice in doing this. The exercise is, what is the log of the following numbers? And so the first number is 12. Well, 12 can be factored. There are several ways to factor it, but I'm going to write, let me get a different colored pen. Let's take 12 is equal to, let's take 3 times 4, and that is equal to 10 to the 0.477 times 10 to the 0.602, and therefore, since I am multiplying these two numbers, this is equal to 10 to the 0.477 plus 0.602. Again, when we multiply here, when we multiply these two numbers, we add their exponents. And that's equal to 10 to the 0. Or not actually 0, 1.07. No, actually, I'm sorry about that. I should never do these things without my scratch paper. So I'm going to add this over here on my scratch paper. 0.477, 0.602. This is 9, this is 7, this is 6 and 4 is 10. Yeah, 1.079. It was. Oh well, 1.079. And therefore, the log of 12 is equal to the log of 3 times 4 equals the log of 3 plus the log of 4 equals 1.079. And now the next example we're going to do is 14, example B. Now 14 can easily be factored, is equal to 2 times 7, which is equal to 10 to the 0.301 times 10 to the 0.845, which is equal to 10 to the 0.301 plus 0.845, which I have to go over to my scratch paper again. 0.301, 0.845 is 6, 4, 8 and 3 is 11, So that's equal to 10 to the 1.146. And therefore, the log of 14 equals the log of 2 times 7 equals the log of 2 plus the log of 7, which is equal to 1.146. And now, for the next two numbers, I'm going to probably have to shift this down just a little bit. G and H. G is 1/4. Okay, the log of 1/4, or actually 1/4, is equal to 10 to the 0.0th power over 10 to the 0.602. Okay, now we have to take into account what do I do when I divide two numbers, two exponential numbers with a common base. And this comes down to what I've been saying all along, knowing when to add and when to multiply. In this case, when I divide two numbers, I subtract from one from the other, and this is equal to 10 to the 0.0 minus 0.602, which is equal to 10 to the minus 0.602. And therefore, the log of 1/4 is equal to the log of 1 minus the log of 4, and that is equal to minus 0.602. Another way of looking at this is we could re-express this 1/4 as equal to, or we could say log of 1/4 equals log of 4 to the minus 1 power, and use that multiplicative power to be that's equals minus 1 times the log of 4, which equals minus 0.602. So we could also get the same result in this case, going that way using the rules when raising a power. So it all comes down to knowing when to add and when to subtract. I add or subtract or multiply and divide. Now I'm going to do the last one, which was, what was it? I said H, I believe, yeah, 2/3. To emphasize this point. H, which is 2/3. Well, 2/3 equals 10 to the 0.301 over 10 to the 0.477, which is equal to 10 to the 0.301 minus 0.477, which is equal to, now I got to get my scratch paper out and go 0.477, 0.301, and it turns out to be, that's minus 7, minus 1 is 6, 7, 1. So that is equal to 10 to the minus 0.176, and therefore the log of 2/3 equals the log of 2 minus the log of 3 equals minus 0.176. And that will be enough to get you started on the exercise. And you can complete the exercises.